All right, so another review video for the final. This one will be linear inequalities and also just the very beginning of the coordinate system. We'll talk about a few things about linear equations and the coordinate system. All right, so we're going to talk about solving linear inequalities and graphing them. And so generally, we remember when we solve a linear inequality, there are so many solutions that the solutions are generally graphed because we need to show that. And then we're also going to just practice the interval notation. So I'm just going to do two examples. And remember that the only thing you have to worry about, you solve these the same way you do linear equations, except if you multiply or divide by a negative. So when you're trying to solve, if your process, you have to multiply or divide by a negative number, you need to flip the inequality. So just change the direction of the inequality if that's the case. Okay, otherwise everything's the same as linear equations. All right, so let's start with number one. We have 4x minus 3 less than or equal to 2x minus 5. So this looks very much like an equation, but we do have the inequality there. So the inequality stays. We don't take that out and change it to an equal sign. You're going to just line up your inequalities instead of your equal signs. I'll wait till I do the next step and then we'll write that down. So we're going to do the same process that we would do if this was an equation, and we're going to try to get the x's terms on one side and the constant on the other. So I'm going to start by moving the smaller x term. So I'm going to subtract 2x from both sides. And again, sides being defined by the inequality symbol instead of the equation, instead of an equal sign, but it's the same thing. So that stays there. On the left, you'll have 4x minus 2x. So that's 2x, and then minus 3, because that stays the same. Remember to change your subtractions to add the opposite if you've been making a lot of sign errors. On the right-hand side, 2x minus 2x is 0, and then be very careful to see that what's left is going to be a minus 5, because again, your subtraction is really add the opposite, so that's a negative 5 that's left. Now I have one side that's mixed and one side that only has a constant, so I'm going to add 3 to both sides because that's the side that has a mixed type. So on the left, your minus 3 plus 3 is 0, so you're going to just have 2x, and you're going to have less than or equal to negative 5 plus 3, which is negative 2. And then like normal solving, I don't want what 2x is, I want what 1x is, so I'm going to divide by 2. Now, what I'm dividing by is positive. The only time I have an issue is if I multiply or divide by a negative. I do not have a negative, so I don't do anything different. I just leave the inequality sign. So I'm going to have x is less than or equal to negative 1. So that's the solution, but then most of the time it's going to tell you to graph it on a number line. So on the number line, I don't really care about if there's a bunch of marks on it, like if they're already there and you want to put some numbers in there, you can. But you can also just say, hey, right here is negative 1. So it doesn't, you don't have to label them all, but if you want to, you could go ahead and put some numbers here, but it's not necessary. And on the next one, I won't put the numbers there at all. So I'm going to graph x is less than or equal to. So the or equal to part is what tells us that negative 1 is included. It says x is less than, so I'm going to shade to the left. So included, remember, is a bracket. So we put a bracket right on negative 1, not near negative 1, but right on that hash mark that's right there at negative 1. And then we shade to the left because less than is to the left. And then also shade the arrows to show that we're shading this whole thing. It continues to go this way. And again, this was a square bracket. okay, because it's included. Then it also says go ahead and do the interval notation, so we'll practice that too. Remember, the arrow is an infinity. Since it's over here on the left, it's a minus infinity because those are the negative numbers on the left, up to the -1, and -1 was included. And so that's what your interval notation would look like. All right, so let's go to number 2. So on number 2, just like anything else, we look, and the very first thing we do is there something we can do to simplify. So on the left, we're good. We don't have like terms, there's no distributing, there's no fractions. On the right, however, we do have like terms. We have 5x minus 2x. So the left-hand side is okay, but the right-hand side, so leave the inequality, the right-hand side has like terms which we can combine, and that would become a 3x. Now, I'm going to purposely do this in a weird way just to show you what would happen. So I'm going to move this 3x to the other side. So I'm going to forget the fact that this side's mixed and this one's not. I'm just going to go ahead and decide, okay, I'm going to subtract 3x because maybe that's what I saw first. So that's what I'm going to do first. So I'm going to subtract 3x from both sides. And this is where a lot of times students get really confused because they don't know what to do, because 3x minus 3x is what we ended up with on the right. So they just end up disappearing that and there's nothing there. But I've said it 100 times. 3x minus 3x is 0. That's not nothing. There's not just a blank there. There's nothing to add it to. So it is a 0 there. Then on the right-hand side, you're going to have 2x minus 3x. That's a minus 1x. Put the 1 or don't. And then it's still a minus 4. Now we need to solve by getting the constant out of that side. So we're going to add 4 to both sides. Remember, there's always two sides. You never can just make a side disappear and there's no inequality sign or equal sign again. That doesn't happen. It has to be there. Something has to be on each side. So on the left, we're going to have a minus x or a minus 1x. -4 plus 4 is 0. Since it's being added to something, only the something is left. On the right, you have 0 plus 4, which is 4. Now, I'm going to move this number line out of my way a little bit, just real quick. I'll have to move my little arrows that I made. All right. So now we'll finish. So now I'm not done because it doesn't say x is greater than or less than. It says minus x or minus 1x. So just like normal, I'm going to divide by whatever's in front of the x, which is -1. But what did I just do? I just divided by a negative, which means on the next line, I'm going to flip the inequality. So instead of greater than, it's now less than. That's what happens when you're solving and you need to multiply or divide by negative. So I just have x on the left and -4 on the right. So now let's graph that. So again, I would just put -4 on the number line. I'm graphing x is less than -4. So less is left. It's less than, so it's not included. So we do not include the -4. So we just put a bracket, but it has to touch that hash mark that has the -4 on it. And then we're just going to shade to the left. And notice it doesn't matter if I use a different color because I'm making it super obvious that I shaded that side. It's much thicker. I made the arrows bigger. We can see we went from -4 to the left. Now I need to do my interval notation. So again, just like the other one, the arrow is an infinity, but since it's the left arrow, it's a minus infinity, comma, up to -4, and -4 is not included. Okay, so there's your review of inequalities. Okay, now we're going to talk about the coordinate system, and just basically in this part of the video, all we're going to do is name ordered pairs and then show how ordered pairs are solutions or not solutions. So we're going to practice naming the ordered pairs. You also should be able to plot points, but we're going to go this way. You should be able to go both ways. If I give you the coordinates, you should be able to put them on the graph. So we need to remember that horizontal is X, vertical is Y, positive is to the right and up, negative is down and left, and we just name our points. And the first coordinate on your ordered pairs, they're always X, comma, Y. So if we want to name point A, we're going to name it by this part here will be the X. So we're at 1, 2, 3, 4, 5. 5 for X. And then we go up 2. So we're at 2 for Y. For B, our X is negative because it's this direction. So we're 1, 2, 3, 4, 5 negative. So B is going to be -5 for the X. And then we count 1, 2, 3, 4, 5, 6 up for the Y. If we go to point C here, our X direction is positive, 1, 2, 3. So we have 3 for the X. And then we go down 2. So down is negative. So the Y coordinate is -2. And then for D, we have 1, 2, 3, 4, 5, 6, 7 in the negative direction. So we have -7 for X, and we're only down 1, so -1. So just make sure you can plot your points. And then we're going to practice that on the next video. We'll graph some linear equations. So now let's talk about how we determine whether an ordered pair is a solution to the given equation. This is also true if you were asked, is a certain any number, anything, a solution to an equation? So it might only have one variable in it, but the process is the same. I want to know if I substitute these numbers, of course the first number is going to be your X and the second one's going to be Y. If I substitute them here, do I get a true statement or not? Since there are infinitely many answers that are true here, I have to check all 3 of them. I have to determine each of them. Just because one of them works doesn't mean the other ones don't work. Okay, so that's a common mistake on tests. We just picked one and said, oh, that one works, and so we just stopped. But they could all work, or none of them could work. We don't know. So we have to determine. Anytime something says determine, remember you're going to have to show some work. So you also can't determine something by just writing yes or no next to it. That's not determining anything. You have to show how you decided that worked. So what we're going to do is we're going to take the equation that we have and we're going to plug in the values. So for here we have a 2, and then it says up here 2x. So instead of x, I'm going to put 1. So I used a parenthesis there to show where I'm substituting. Plus 3, because that's in the equation, and then y. But instead of y, I'm going to put 3. And then that answer is supposed to equal 11. So I'm going to put a question mark here. Does that equal 11? I don't know. And don't say yes now, because we don't know until we actually show it. Again, we're determining. So until it says 11 equals 11 or something else equals 11, we can't say yes or no. So we're going to use our order of operations here, which would say multiply first. So 2 times 1 is 2, plus, and then we have to do 3 times 3 because we do our multiplications first, which is 9. And then we put equals question mark 11. 2 plus 9, we're just simplifying the left, is 11. So 11 does equal 11. So yes, this is a solution. Then let's try the next one. So I have 0, 4. So same thing. I'm going to plug in. So the formula says 2 times x but instead of x, I'm going to write 0 plus 3 times y, but y in our problem is 4, question mark equals, does that in fact equal 11? So now we simplify. 2 times 0 is 0, plus, again, we do all our multiplications first, 12. Does that equal 11? Well, the left-hand side is 12. The right-hand side is 11. You can just put not equal to there. So this is not a solution. Okay, and here we should say yes, a solution, because we shouldn't just say yes. It is a solution. Okay, now let's try the last one. And remember, we have to try all of them because all of them could work, or 2 of them could work, 1 of them could work, none of them could work. We don't know. So we got to try them all. So we do the same thing. We have 2 times x, but our x is -2, plus 3 times y. The y here is 5, equals question mark, because we don't know, does that equal 11? So we do our multiplications first. So we have -4 plus 15 equals question mark 11. Then we add, what's -4 plus 15? That is 11. 11 does equal 11, so yes, this is a solution. Okay, so that's how we determine if something's a solution. And that's true for linear equations in 2 variables, which is what we have, or a single variable. So if you have an equation that only had x's in it, and they want to know, is x equal 3 a solution? You would simply plug it in to all the x's and then see if the equation is true. Okay, so that's going to be it for this video.